Okay, good morning. Welcome to
SuperMath number 27.
SuperMath27. So today we started talking about area for the first time, which is really fun. And we talked about the area of a rectangle. And if a rectangle has one side A and one side B, how do you find its area?
Well, you multiply A times B.
Okay. And how come that works?
Well, because this side, because if you draw a grid, this side is B squares long,
Okay.
and this side's A squares.
All right.
So
And so we
A
have,
rows of B, or B rows of A.
okay. So we get A times B is the area. And we also talked, it's still on the board behind you actually, we also talked about right triangles. So in a right triangle, if it was A high and B long, and this was a 90-degree angle,
It's half of A and B,
how come?
because this is half of a full rectangle.
All right, so we got half of a full rectangle. Now we're going to talk about triangles in general, actually. And it's going to be pretty interesting. We'll start with a simple case, and maybe that will be the only case we do in a 5-minute movie, where we have a triangle, kind of a funny shaped triangle, no right angles. Let's say this is, I don't know, 10 long, and let's say, how high do you want it to be? Pick a number.
Let's do 15 high.
Alright, let's say it's 15 high. 10 long and 15 high. How are we going to find the area here?
Well, we did in an earlier movie that a point dropped from this height of this triangle is the midpoint. Sometimes.
It's not going to be true in general. The height is when you come straight down and you hit it with a right angle
Yeah,
here.
but in our isosceles triangle, that's...
In an isosceles triangle, that's true. In a more general triangle, in an obtuse triangle, by the way, it's
Not
maybe
even,
the easiest to see that that's not going to be the midpoint. Because why?
it's not even in the triangle.
It's not even in the triangle. Yeah.
So what can we do here?
What can we do here?
We have two right triangles that it made.
We do have two right triangles that it made. So how did we find the area of right triangles?
Well, it's the area of a rectangle with their sides cut in half.
Okay, why don't you draw the other rectangle there too? Okay, what can you tell me about the rectangle that you've sort of sketched on the board?
The big one?
Yeah.
It's 10 by 15,
Okay.
because 15 is the side.
Alright, so we know this rectangle is 15 high and 10 long, but that rectangle doesn't really exist, but it does help us understand something about our triangle. What does it help us understand?
Well, this is twice the area of the triangle.
How come?
Because this triangle is half of this rectangle, the smaller one,
Alright,
and it's the same for this one.
okay. So how will I find the area of my triangle then?
So, the area of the huge rectangle is 150. Then, you have to divide this by 2, because it's half of what we're looking for.
Alright,
So you get 75.
okay. So for a triangle, for this triangle here, if instead the base was A and the height was B, what would our formula be for the area of a triangle?
It's 1/2 A times B.
Okay, or 1/2 base times height. Okay. Now the interesting thing will be, and we'll probably talk about this tomorrow, I don't mean to make dotted lines, what about my obtuse triangle? Here we were able to form two triangles, draw a rectangle, and see that it was half. But here, when I drop this perpendicular down over here, I certainly haven't cut my triangle into two pieces.
Yeah.
But I do seem to be able to form a rectangle. And we'll have to see if our idea here somehow extends to the situation where we have an obtuse triangle. But we're not going to do that now because we've probably already exceeded 5 minutes. But you can see that the area formula for a triangle does seem to follow very quickly from the area formula for a rectangle. All right. Good job. Good job.